So today we're going to look at quadratic graphs. So quadratic graphs now have a indice on our x term. So we have to have an x squared term there. So we have it in the general form of y equals ax squared plus bx plus c, where the a, b, and c are just constants. They're just numbers. So the easiest one we could have is this, where we have a is 1, b is 0, and c is 0. So we get y equals x squared, and that's our most basic graph that most people and places start with. So when we actually plot them, they're going to be a U shape. So that means that they'll have a minimum, right, at the bottom of the U, and it's positive for x squared, or an N shape if it's negative x squared. So you'll see where this actually, what it looks like when we start plotting them. And so we have examples of some quadratic graphs. Like I said, the easiest one is y equals x squared. And we have 2x squared, we have negative x squared, we have negative 2x squared, we have 2x squared plus x, negative 2x squared plus 3x plus 1, as kind of showing where can we go with all this. We have all these numbers, right? And we're not going to do plotting from the equation of a line because that's kind of more advanced. We're going to start off just how we always start off. So we're going to start off with plotting. So methodology to graph quadratics is we're going to draw our x and y values. So it's just substitution again, but we just have to deal with one more term. So we're going to substitute in just like we've done before, but I would leave yourself a lot more room because you have to do a lot more work to solve these out. But there are some little tricks that you can do once you spot a little bit of a trend. So we're going to work with this example. I alluded to it earlier, so graph the function y equals x squared between the values of negative 3 and 3 for our x. So that means we're going to take on the x values of negative 3, negative 2, negative 1, 0, 1, 2, and 3. So that means 7 substitutions, 7 calculations we have to do. But it's the same calculation, just with a different number each time. So we're going to first draw our table, one row for our integer values of x, and one row for values of y we are going to find. So leave the y's blank and fill in the x. So it should look something like this. You could write it as a list from top to bottom, but I quite prefer these more. So pick an x value and substitute into our function y equals x squared. We're going to start with our leftmost because that's how we read a page. So here, we're starting with negative 3. Now, when you actually do these calculations, and because you're going to be using a calculator more often than not, make sure you put your negative 3 in brackets. So press bracket, negative 3, bracket, and then put it all to the power of 2. This is because if you do not, well, we know a negative 3 times negative 3, it's a negative times a negative, that makes a positive. And 3 times 3 is 9. But if you do it on your calculator and you put in negative 3 squared, you are simply going to get negative and then 3 squared, which is negative 9. So keep in mind, make your calculator do the work so you don't have to. But always make sure you know what you're doing. So our first point, we get negative 3 in our x, 9 in our y. Next, we're going to plug in negative 2, so we get y equals bracket negative 2 bracket squared. So negative 2 times negative 2, which is 4. So our point at negative 2 and 4. Next, we have negative 1. So y equals negative 1 squared, which is 1. So our point is negative 1 comma 1. And our other 2 points are x is 0, we get y is 0. And then x is 1, we have y is 1, right? Because 1 times 1 is 1. So we now have 5 of our points. Got to keep going. But notice I want to stop. What do you think the next point could be? Right? So we've gone from negative 3, negative 2, negative 1, 0, and then 1. So, well, look at our y values. We went 9, 4, 1, 0, 1. Well, kind of looks like a pattern. Right? So I'm going to guess that our next point is going to be 4. Because our previous point to 0 was 1. Well, it is. Well, we're going to look at when we're graphing why this happens about, but when we have x is 2, y equals 2 times 2, which is 4. So this is why we start to get these values reoccurring. So really, once you find your minimum or maximum point, which would be, we'll come back and talk to at a later date, you can kind of start to repeat the values. So you only have to do about half the calculations and just be mindful of what's happening with your equation. So lastly, we get 3 times 3, which is 9, just like negative 3 times negative 3 was 9. So we've got our table of values all filled in just on the bottom there, and let's plot it. So we have 7 different points. You can put them in coordinate form if you'd like to. I just leave them in the table of values because I can see it from there. So we need a little bit bigger graph paper this time, and we're going to plot negative 3 and 9 as our first point, right up there. Then our next is negative 2 and 4, and negative 1 and 1, then 0, 0. Now, this is where I said it's going to start repeating, just on the other side of our y-axis. So we have 1, 1, 2, 4, and 3, 9. So once we kind of etch in our line, and you cannot do this with a ruler, just do it as best you can, sketch it in, we are going to get this U shape. Remember, we get a U shape when we have a positive number outside of our x squared, or the x squared term is positive. So, let's do another example. Let's do y equals negative x squared plus 2 this time. So this time we're going to end up with an n shape because we have a negative out front of that x squared. So you know you should have an n shape for what your points. Then we will have this plus 2. Okay, so let's just see what that is going to do. Is it going to do the same as our previous when we did linear, where it's going to start it up at our y-axis, or we're going to start at kind of 2 on our y, and then that'll be our maximum value for our y values? We'll have to see. But I want you to try and think about it and think what is going to happen, because I know what's going to happen. So I'm using the same domain for our x values, so our same how far they're going to spread. That way it just makes your tables the same. So here we pick a value of x and substitute it into our function y equals negative x squared plus 2. So we're going to start with our leftmost value of negative 3 again. So here we're doing negative 3, and so we put in our equation as such. Y equals negative, that's that negative out front, and then we put in negative 3. Well, remember that negative 3 squared is just 9, so we get negative 9 actually there. And then we have to add on 2, so our point is negative 3 and negative 7. Next, we have negative 2, so we're going to get negative, and then remember that's going to be positive 4 inside after we do that all. And so we're going to get negative 4 plus 2, which is negative 2. So next, negative 1, we're going to get negative 1 squared, which is going to be negative 1. Add 2 is 1. Then let's put in 0. We get, well, negative of nothing, it's simply nothing. So we get just the point 2. So 0, 2. And then we have x is 1. We get y equals negative. Well, that's going to be negative 1 there, plus 2. So we have negative 1 plus 2 is 1. And this is where I said you can start looking at your values. So if they start to repeat, we know that our next value is going to be negative 2 and then negative 7. But until you feel confident, I want you to make sure and check at least 1 or 2 more. So here we have 2 and negative 2, and then 3 and negative 7. So we can put in our table and put in all of our points. Now, we're looking back at our example here. We're going to graph this negative x squared plus 2. So we have our values there. I just carried them over. And we now have 7 points, which we can plot again. So we have negative 3, negative 7. Then we have negative 2, negative 1, 1, 0, 2. Oh, and look at that. Well, it seems when we have just an x squared term and a constant, it seems like that it does the same thing as our linear. So it looks like we are still going to start at that just that constant term, because if we substitute in our 0 for x, well, that's like a cover-up, right? We can cover up that, and oh, y is 2 when we don't have an x. So now we're going to repeat our values going down, and we have that N shape start to form. Draw on your line of best fit as best you can, and check your work. So, things that we can start to think of, and I alluded to this before, we'll talk about this again many times, is what is the minimum or maximum value? Okay, so in that last example, we had it as a U. We could talk about our minimum or maximum value. Well, it was, I don't want to confuse you, so we're just going to talk about here. Here we have a maximum value, and that's talking about our Y values, right? So our maximum value of our Y is 2, and that happens at x equals 0. So you just put the point 0 and 2. So y is 2. Then what are the solutions? Well, our solutions is where it crosses the x-axis. Okay, we can actually figure this out through factorization, but we want to be able to know how to do it graphically. So here you just kind of observe on your graph, where does it touch? Well, it touches at 1.5 and negative 1.5. So one thing you answer in terms of y, one you answer in terms of x. So now we have a little bit of questions here. So find the minimum maximum values for these graphs. We've already done number 1. So if you want, you can skip question 1. If you want, I always leave it there, because if you can recreate what I did, then without looking, then you know that you're on the right track, and it's the easiest example. So 6 questions. Now we're going on. Here are our solutions, or our table values. At this point, I want you to check. So checking all your values. Okay, I'm going to go on, and we're going to start checking through our graphs. So your graph should look like this for the first 3. I'm going to go on in about 3 seconds. And lastly, these are our last 3 graphs. So now I asked you to think about our x and y values, right? And I'm just going to talk through them. So here on our graph 1, our minimum would be our y is 0, right? Our solutions is where we only have one solution, sometimes called a trivial solution, where x is equal to 0. Next, we have a maximum where y is equal to 0, and we have our solution again is x equals 0. Then we have a minimum for number 3 at y is negative 10, and we have our solutions at, well, you can only do your best to approximate, so I'm going to guess that's about halfway through a half block, so that's negative 2.25, and x is 2.25. Then here, we have a maximum of 10, and our solutions are, again, negative 2.25 and 2.25 for x. Question 5, our minimum is 0, and our solutions are 0. And same thing for 6. Our solutions are 0, and our minimum is 0. So here are our solutions to our questions, our minimum and max values. So check your answers below. And one thing I want to point out is, as we get down to our kind of question 3 onwards, you notice for B, the solutions are very awkward and weird. If you got somewhere around 2.25, right, like I'd said before, then that's fine. I showed it actually as root 5 and negative root 5 because that's what it would be after factorization and actually doing some other little work. But you only have to approximate it doing graphical. You don't have to be spot on. So see you in the next video where we'll do some more quadratics.